Good morning. Uh, Time for our first assignment. So this is Mr. Hendrickson. I hope everyone's doing well. Starting this week now, we're doing our live lessons. So we're doing remote learning. So my plan is I'm going to attach the first worksheet. The first page will be directions and me showing you how to do the work, and the second page will be for your assignment that you need to do. You'll need to complete both pages and submit them to me on Teams so that I can check off your work. It'll be graded based on effort, but I will have to make corrections, and you will have to make corrections as well sometimes if there's problems. But hopefully it all goes well. This is our first shot at it. So I'm going to start with this first worksheet. So if you follow along, we can go through the definitions and the answers to what we're supposed to do. Hang on. All right, for our first lesson, we will be doing exploring graphs of quadratic functions. The main definitions and the main parts that we're going to be looking for, we need to know what the y-intercept is, the x-intercept, the vertex, the axis of symmetry, and end behavior on quadratic functions. So hopefully remember that quadratic functions are the parabolas. So I have a couple of examples here that I'm going to run through and fill out these key things, and that's what we're supposed to follow and learn for today. So the first idea is the y-intercept. So over on the side here, it makes sense to write y-intercept. And the y-intercept is where the graph crosses the y-axis. So I'm going to put the y-axis up here. This will be the x-axis. So you follow the y-axis and see where it crosses, and it crosses at this point. And when you label it, you want to make sure that you say that it's the y value. So y equals 3. That would be the y-intercept. For the x-intercept, for some quadratics, we can have different amounts of x-intercepts. Sometimes you can have 2 intercepts, you can also have 1 intercept, or you might have no intercepts if it does not cross the x-axis. So we want to find where it crosses the x-axis, and in this particular graph, for this quadratic, it does it in 2 spots, so we will get 2 answers there. It may help under x-intercept to put that there may be 2, 1, or 0 for that. For this one, we're going to get 2 x-intercepts. And again, it's important to label them with which letter. So this will be x equals 1 or x equals 3. Those are the 2 points where it crosses the x-axis. For the vertex is a point. It is going to be the highest point or the lowest point. We usually refer to that as the max or the min. So the vertex on this one, because it opens up, the vertex will be at the bottom, so it will be a min, and it's the point. So we label that with a coordinate 2, -1, the ordered pair 2, -1. The axis of symmetry, this is going to be a line in the middle of our quadratic function. So in the middle of the parabola, if you already have the vertex, the axis of symmetry is the line at this x value. So all you have to do is find the middle, and I like to draw the axis of symmetry in. I usually do it as a dotted line, put arrows on it, and it has an equation of x equals 2. So whatever the vertex, the x value of the vertex is where we find the axis of symmetry, and we just make it that equation of a line. So it's going to be up the middle. The last thing we need to do are the end behaviors. And for the end behaviors, we're referring to what happens on the ends for the left and the right. So if I go all the way to the left, which way does my graph go? And if I go all the way to the right, which way does my graph go? So the terminology, the way we write it, is a little different. So I'm going to write for the left side here, I want to know as x approaches -infinity. That means I'm going all the way to the left on this graph. And if you look at your parabola on the left, which direction is it heading? It's heading up. So we say the y value approaches +infinity because it goes up forever. So for the left side, I'll even put up in parentheses there. As x approaches -infinity, going to the left, the y value goes up to +infinity. On the right end behavior, what happens as I move to the right? So I still write that as x approaches. Now when I go to the right, that's going to positive infinity. So if I went all the way to the right forever, this would keep going up. So the y value, since it's going up, it also goes up to positive infinity. So that one's also going up. So those are the key factors, the key features of the quadratic function that we need to study. The y-intercept, the x-intercept, the vertex, the axis of symmetry, and the end behaviors. Now I'm going to go through the next example, and I'll go through the same features, so hopefully it's a little bit easier and you can follow along. Again, if we start with the y-intercept for this graph, I find where it crosses the y-axis, which would be at this point. So I'm going to write y equals 0, because that's at the point 0, 0. For the x-intercepts, again, this one has 2. They don't always have 2. Sometimes you could have just 1 if the vertex hit right at the x-axis, or you might not have any if it doesn't hit the x-axis. But for this one, the y-intercept, the x-intercepts, sorry, are here and here. So I'm going to get x equals -4 or x equals 0. So again, this one has 2 x-intercepts. The next feature I'm looking for is the vertex, which is the max or the min of the graph. So I want to find the top or the bottom. In this case, this one's going to be a max, and here's the vertex at the top, and that has the coordinates, so I do the ordered pair, -2, 4. The axis of symmetry, again, is the line that's in the middle of my parabola. So I do need an equation of a line. And again, once I find the vertex, I know that's the middle, and the line just follows that x value. And my axis of symmetry will be the line x equals -2. So you find the x value of that vertex. And again, the last concept that we're concerned about here are the end behaviors. And when I say end behaviors, I'm referring to what happens way on the left and way on the right. So I like to label it and say on the left side, that's going to be as the x value approaches -infinity, going all the way to the left, what happens to the y values? So I look at my graph, and as I go to the left, this graph is heading downward. And I'll even put an arrow at the bottom of that. So my y is going down, which means -infinity. I usually write down there. On the right side, I want to know what happens as the graph moves to the right. So this is as x approaches positive infinity. That's going all the way to the right. And again, this one is heading in a downward direction. So I'm going to say my y approaches -infinity. That's going down. So there's the first page that you should be printing this out and filling in the same information that I have on this page. Your assignment is to complete the second page, which has 3 examples, so you have to do the 3 on your own. But you still need to fill out the first page. So when you submit your work, please submit both pages that show both work. It works best if you do it as a video or scan your answers instead of taking a picture, because if you scan it, it comes out as one document when it gets sent to me on Teams. So hopefully that works out well. Good luck with all that. If you have any questions, I'll be checking my emails regularly tomorrow. So hopefully you get it done. It's due Monday at midnight, so you have all day. I wouldn't wait till the last minute in case you have questions, so you can submit them. Like I said, I will check my emails regularly. And good luck.